Welcome back to this video series of C++ programming. This is the lecture 16 of this video series, and today we are going to talk about dynamic memory allocation in C++ programming. There are two ways the memory can be allocated in C++. The one is static memory allocation and second is dynamic memory allocation. In static memory allocation, the memory is allocated during the compilation time. That means the variables or objects which are created in your program, except the local variables or objects, the memory is allocated during the compilation time. And the variables or objects those are allocated the memory during the compilation time are stored into a data RAM or the data memory. But in case of dynamic memory allocation, the memory is allocated during the runtime. That means while your program is running, the memory can be allocated to those variables. Not only that, you can free that memory once it is allocated or once the use of those variables or object is over. The dynamic memory allocation provides you flexibility in terms of variables and object sizes. So in case of a static memory allocation, typically the size of a variable or object is fixed. But in case of dynamic memory allocation, you can change or vary the size of variables or objects as per your need. Let's talk about some of the important points of this dynamic memory allocation. First, C++ provide two dynamic allocation operators, the new and the delete. The new is used to allocate the memory dynamically and delete is used to free that allocated memory. The second point, C++ also supports dynamic memory allocation function called malloc and free. These are included for the sake of compatibility with C. So these malloc and free functions are actually from the C programming, and still C++ still provide the support for these functions. However, for C++ code you should use the new and delete operators because they have several advantages which we'll talk in this video. The new operator allocates memory and returns a pointer to start of it, and the delete operator frees memory previously allocated using that new operator. Let's see the syntax of a new and delete operator. This is the type. So type can be an integer, float, or character, or it can be any user-defined type. And what follows after this type is the pointer variable. That means this variable will point to a memory that is going to be allocated dynamically. And this is the assignment operator, and after that you have to specify the new keyword. And what follows after this is again a type. So in this case, the type as we talked here, it can be a standard type or user defined type. Now the memory is the size of dynamically allocated memory, it depends on this type. For example, if your type is an integer, then this new variable allocate the size of equal to integer type. So for example, if integer is a 32 bits, that means this new variable will allocate the 32-bit or 4-byte of memory. And then this is the syntax for delete. So to specify the delete operator and then the name of that pointer variable which is pointing to this memory or previous memory allocation. Let's understand how this dynamic memory allocation works. Assume this is your memory block, and here we are specifying one integer pointer variable called as PD, and we're using this new operator to allocate the memory which is of a type integer. So that means 2 bytes of memory will be allocated dynamically, and this PD will point to that memory location which is allocated. So if in this case assume now this new allocated a memory of the 2 bytes starting from the address 1000x and up to the 1001x, by considering the fact that integer is 2 bytes wide. That means the 2 byte of memory is allocated using this new operator, and now PD will point to this memory block. So it is actually pointing to the start of this memory block. So it's pointing to this 1000x location. This statement can be written in this way. Now this is like in place declaration of this in place definition of this PD pointer variable. So you can define that in the another line. Here in this case, the memory is allocated for the float variable. Now suppose if the float variable is of a 4 byte, the 4 byte of memory will be allocated starting from the address 1000 to 1003. Here the brackets and the value specified within the brackets is the initialized value. Now when you don't specify any value after this new type, this it will hold the garbage value, but you can initialize this dynamic memory with the values provided through this brackets, and this value should be of this particular type. So if it is float, so it should be of the float type. You can, along with the variables, you can initialize or you can create the dynamic memory for objects. So in this case, this is the object name, and this is the new operator, and then the class name. And then based on the size of an object, the memory is allocated. This is how the dynamic memory allocation works in C++ programming. Let's understand this dynamic memory allocation with an example. First, we'll create this variable, integer pointer, and we'll use this new operator, and then this type of this, that you have to specify the type. Now in this case, we are allocating memory dynamically, which is of a size int. So in this case, if integer is a 4 byte, we'll be allocating the 4 bytes of a memory. Now this memory allocation, now this memory is allocated in the special section of your RAM, and that is called the heap. So unlike the normal variables which are stored into a data memory, this the variables which are allocated memory dynamically are stored into a special section of RAM called as a heap, and this section is typically a compilation configurable. That means you can change the size of heap during your compilation time. So we have created one pointer variable, and now this pointer variable is pointing to a memory allocated using this new operator, and this is the type. So that means we are allocating the memory of a size equal to integer type. Now let's assign some value to this pointer variable. When you assign the value to this pointer variable, actually you're storing this value into this dynamically allocated space, right? So this 40 variable will be stored into a memory location to which this p is pointing. And now try to print this value, and let's try to print this value onto the console window, and now it should print the output as 40. So this is how this dynamic memory allocation is used. As we talked before, we can initialize the dynamically allocated memory by specifying the initialized value after this type. So in this case, this 20 value will be assigned to the memory allocated using this new operator. So in this case, if we try to print the output, it should print the value of that memory location as 20, as you can see here. And then the memory can be free using this delete operator. Once you use this delete and this variable pointer variable p, now that memory which was allocated dynamically in this statement is now no more available. So that means it is that means now that memory can be utilized for storing some other data. Let's talk about this important point, and that is error handling for new. What is the meaning of error handling for new? To understand that, here this new will allocate a memory dynamically in your heap, But suppose if there is not enough memory or enough heap memory in your target processor, then there is an issue. That means you are not pointing to the some correct memory. If your compiler is not able to allocate a certain memory in your program, then this p variable might not point to a correct memory, and that's why you need to handle the error that is written by this new operator. So typically, when you try to allocate the memory and there is not enough space or there is an error in the memory allocation, then this new will return an error. So this we can handle this error to avoid uh, the issues in your program. So if memory is not allocated and if you try to dereference this variable or try to use that pointer variable, then it might actually access the another memory. If you're writing to that memory location, it might corrupt that memory location. It can be anything. It can be your code, and that might result into a system crashes. So you must handle the error written by this new operator. So how to handle that error? In C programming, the malloc and calloc returns null if memory is not allocated dynamically. So they return the null pointer, and then we can check for that null pointer to see if the memory is allocated or not. The actions of new on failure is a compiler dependent in C++. So as per C++ standard, the action of new is compiler dependent. When C++ was first invented, the new returned null on failure. Later, this was changed such that new causes an exception on failure. So later it was changed so that the null the new will return the exception, and we will handle that exception to determine the and we will handle that exception to take care of that memory allocation issue. And finally, it was decided that the new failure will generate an exception by default, but that a null pointer could be returned instead as an option. Thus, the new has been implemented differently at different time by compiler manufacturers. So it depends on your compiler how this compiler handles this error written by the new operator. Typically, for this Microsoft Visual Studio, it can handle the error written as a null, and even it can handle the error written through the exception. So let's talk about how this error handling is working. First, we'll see how the error handling with this null is work. So if this new has written the error due to the memory size issue or memory is not available, how to handle that error is to check for the null condition. So what is null? Null is basically a zero value, or when you are using the pointer will point to some memory location which will be a valid memory location, or rather it is basically an address which will be more than 0. But if it is the null means it is pointing to the 0th memory location, which is actually not a valid memory location, right? Your program starts above that 0th location. So if your this new operator is returning the null, that means a 0, that means the memory is not allocated properly. If the memory is allocated properly, as we talked here, it will return the base address of that variable. So in this case, it should return the proper value. That PD will point to a proper memory location. But in case of failures, it will return a null pointer. So we can handle this using these two equal signs. We can handle that error. If you are getting the null, that means there's an issue in the memory allocation, and then we can indicate that to the program, or you can take some certain action. But if it is not returning the null, that means your memory is allocated successfully. So in this case, if I try to put the statement here and try to print, then it should print the output value as 1020 if memory is allocated successfully. Otherwise, it should print this output as error. So let's compile the program and let's see what does it outputs. And it is outputting the value as 20. So that means there is enough heap memory available in on target processor for which I'm running this program. So it's not returning any null pointer for this p variable. There is another way, as we talked, to handle the error, and that is using the exception. So how to handle the exception? Here, the exception are handled in the C++ programming using the try and catch. So try is one C++ keyword. Now inside this, I will add this code here inside this try, and then followed with this catch. So what is try and catch? If this statement, in this case, if there is an issue or any error written by this new operator, it will go into this catch loop, and then we can handle that error inside this catch. Otherwise, we can the error won't be generated and the normal code will be resumed. So here then we can, but here you have to specify the type of error. So now in this case it's a bad alloc. That means there is a problem with the allocation. And then probably you can return from your program at this place. So if there is no error, then it should come here, and then it should print the value of this the memory dynamic memory allocation. However, now here it is giving an error that identifier p is undefined. The reason is it is defined in this try. So now the scope of this variable is local to this block. The block in the sense the content which is present in this two curly brackets, now it becomes one block. So now this p variable is present within that block. So I have to move this variable outside this block. I'll specify it here, and here using we can now assign the value of new to this p variable. And now let's compile the program. So it is outputting the value as 20. So we saw how we can handle the error written by a new operator using the exception, that is try and catch. As we talked before, the new operators provides the advantages over the malloc and the malloc operator in C programming. And that advantage is new automatically allocates enough memory to hold an object of the specified type. So you do not have to use the size of operator that you typically use in the malloc. When you allocate the memory using the malloc, you have to specify the size of operator and then the type of that particular variable. But in case of a new, it is not required. You have to just specify the type, and then the size will be taken care automatically by the compiler. And because the size is computed automatically, it eliminates any possibility of error in this case. Second point, new automatically returns a pointer of the specified type. You don't need to use an explicit typecast as you do in the allocating memory using the malloc. So if you're from the C programming background, you must be knowing that when you are returning the value from the malloc, which is actually a pointer, you have to provide the specific typecast, or you have to typecast this malloc to a proper type. For example, if you are allocating the memory for the variable which is of an integer type, then you have to typecast this malloc variable with that integer type. So this is how you have to do in the C programming. But in C++ programming, it is not required when you use the new operator. The explicit typecasting is not required. And the third point, new and delete can be overloaded, allowing you to create a customized allocation systems. So this is the part of operator overloading. So the new and delete operators can be overloaded so that they can be used as per the uh, user purpose. Arrays can also be allocated dynamically. So this is the syntax how the arrays can be allocated. So here this is a pointer variable which will point to a memory allocated dynamically, and in this case it is an array of integer which is of 10 bytes, or it is a 10-byte integer array. Now in this case the 10 integer bytes will be allocated dynamically in the consecutive memory locations. Suppose now this is of integer, so an integer variable will hold the 2 bytes of memory, assume considering the size of integer as a 2 byte. So when you say specify the value as a 10, that means the 20 bytes of memory will be allocated in the consecutively, and p will point to the start address of that memory locations, or the base address of that memory locations. Then this memory can be freed using this syntax. So here you have to use the delete, then these two square brackets followed with the name of that pointer variable. So this is how this dynamic memory allocation is used with the uh, arrays. And one restriction applies to this allocating arrays. They may not be given initial values. So unlike the variables, you can provide the initial values to those variables. So this by default they might contain the garbage values. Similar to variables, the dynamic memory allocation can be done with objects as well. So this is like creating the memory allocation similar to a variables. But the only difference is when you create a when you allocate the memory dynamically to objects, the constructor function which is created is called. So as soon as you create object, the constructor function is called, and whenever the object is free, the destructor function is executed. Let's understand this point. So for that purpose, I will create one class here, call this as my class, and inside this we'll create some public data members. We'll call that as a integer data one, and here we'll create an object of that class. Now here we'll allocate the memory dynamically. So as we saw, how to allocate the memory dynamically is to provide this new operator and then the name of that class, and here it must be a pointer. Now this object pointer will point to a memory allocated using this new operator, and the size of this memory will be equal to the size of this my class. That means the size of all the data members present within this class. And you can initialize the value when you create this object. So suppose now I'm initializing the value here. When value has 20, then now to initialize the value I will create the constructor function, because as we know, when you create an object and if you specify any parameters to that object, we must handle them through the constructor. So here create one constructor. Now this is a parameterized constructor. It will take the parameter. So here we are passing only one value, so there will be only one parameter, and we'll assign this value to this data variable. So this is how the dynamic memory allocation can be used with the objects. It is similar to creating the dynamic memory allocation for the variables. One more point, when you delete this object, which is done using this delete operator and then the name of that object, you're actually freeing this object. And when you do that, the destructor function is called, which is the case when you destroy the normal object, or when that normal object is no more use. For dynamically allocated objects also, the constructor and destructor functions are applicable. Dynamic memory allocation can be done for the array of objects as well. So similar to array, you can allocate the dynamic memory to the array of objects. No array allocated by new can have an initializer. You must make sure that if the class contains constructor functions, one will be parameterless. That means when you create an array of objects and allocate dynamic memory to them, you cannot initialize it. That means you have to specify the parameterless constructor in your program. If you don't, the C++ compiler will not find a matching constructor when you attempt to allocate the array, and will not compile your program. When deleting an array of dynamically allocated objects, a destructor function can be called for each object in the array. So if there are for n number of objects, the n number of destructor functions will be called. And one last point, that is about the no-throw alternative. As we talk, there are two ways the errors are handled in the while returning from the new operator. The one is using the null pointer, and another is using the exceptions, and that is compiler dependent. But if suppose your in standard C++, it is possible to have the new return null instead of throwing an exception when the allocation failure occurs. And this form of a new is most useful when you are compiling older code with the modern C++ compiler. If your code is very old, that is C program, and if you're trying to compile with the new compilers which handle the error from new as using the exception, then there might be an issue. So in this case, it is also valuable when you are replacing the calls to malloc with new. So if you're using putting your C program into C++, then you might want to replace all the mallocs with the new. And in that case, it is also useful to use this the new method of error handling, that is exception, rather than using the null pointers. So in this form of this no throw alternative, what you have to do is you have to specify this no throw alternative keyword within these two brackets after the new. That means now your the error will not be handled as an exception. It will be handled as using the null pointer. Alright, so this is all about the dynamic memory allocation in C++ programming. I hope now you have able to understand the different concepts of dynamic memory allocation. So for now, thanks for watching this video and stay tuned for the upcoming videos.